Hi, my name is Minal.
I'm Amy. And I'm Melissa.
And we are going to be talking about conjugation versus wavelength.
Color versus viscosity and acidity.
How to use the UV-VIS and general dilutions. This is the conjugation of bonds versus the wavelengths. As the conjugation of bonds increases, the wavelength also increases. The higher the wavelength, the electronegativity increases and the pH is lowered. Also the bond angles, the SP3, SP2, and SP1, as this lowers, the pK value also lowers and the acidity increases of the malachite. Alright, so here is the malachite green. We are diluting it to the line. Okay, so my first solution, I'm going to put 100 milliliters of the malachite green. In the second, I just added 100 to it. And I'm actually going to bump it up to these are microliters. I bumped it up to 300, so total it's going to be 400 in there. 800 microliters. Dilute it with 10 milliliters of water. So these are going to be our 3 dilution factors, and it looks like on tape that you can't really see it. I'm going to hold it up against a different color background, and you can see there is increasing color. Malachite green, you can see there's 22 electrons in the pi system, and it really looks more of a blue color. We have the dilutions over here. You can see when we do the dilutions, you want each one successively a difference in color. When we come over to the UV-VIS, we started with a blank. We started by blanking it, and these are our 3 cuvette samples. So malachite green absorbs a wavelength of about 617 nanometers, and these are our dilutions, so the stronger our concentration, the more it is going to absorb at that level. Here's the structure for it. There are 22 electrons in the pi system. This dye is normally used for clothes, like your blue jeans, and what else? The royals used it for a lot of their clothing as well. Hi, so this is the indigo dye. It was not dissolving in water, so we used dimethyl sulfoxide to dissolve it into it, and then we did a dilution over here. The dilutions are serial dilutions. You can see the concentration increases, starting with the blank, which is 0. I'm just going to give some fun facts about our indigo right here in the structure. It's not actually an azo dye, and the chromophore group for indigo is actually the central group here without the phenols. And there actually is some hydrogen bonding that occurs between the amino group and oxygens on both the top and the bottom, which actually increases the conjugation of the system, and that's actually one of the reasons why indigo has such a dark color. When you basify indigo, with some NaOH here, it actually comes out of solution and it no longer has its dark color. As you can see, it's turning clear there. So that's pretty cool. Alright, so this is our yellow azo dye, as you can see, and it has 20 electrons in its pi system. Alright, so right now I have been dissolving our yellow azo dye in water because it's water soluble. So here's the dye.
I dissolved 0.005 grams of the dye in 500 milliliters of water. Alright, so now I'm going to do our dilution of our yellow azo dye. So I'm going to start with 10 milliliters of our dye or our dye solution in 10 milliliters of water. Alright, so this is 5 milliliters. And this is another 5 milliliters. And now I'm going to add water to that to dilute it. Alright, here goes 10 milliliters of water. For our second solution, we're going to do 5 milliliters of our dye solution and 10 milliliters of water. Alright, so here goes 5 milliliters. And 10 milliliters of water. Alright, and you can see that one's looking a little more diluted than the first one. And then for our third dilution, we're going to do 2 milliliters of our dye solution in 10 milliliters of water. And 10 milliliters of water. There we go. Here are our 3 dilutions. Might be a little hard to see. Alright, so the one on the, well, I guess your left, right? Okay, so this one is the darkest. It's a little hard to tell, but it's definitely darker than the other two. And then as we go, they get lighter. Alright, so this is our red azo dye that we're working with. And it actually has 18 electrons and it's 5 so not very expensive, but...
Hi, so this is the red azo dye. We did a serial dilution for this one. You can see that the lowest concentration is this one and the highest is this one. It's the darkest. We had to use acetone to dissolve it because if it's not dissolving in water. We ran the UV spec on the red azo dye. Here's the dilutions we did. And this is what the graph looks like over here. It's ran at 378 nanometer wavelength. And you have a different absorption depending on the concentration of the light.
The phthalocyanine, there are 42 electrons in the pi system, and it's a very pretty color. It's this blue color, kind of a dark blue. It's really insoluble in organic solvents, so we had to use benzene in order to dissolve it. Unfortunately, we can't basically acidify it to see what would the color change look like because it's going to crash right out. Alright, so these are the phthalocyanine, and you can see the dilutions. The first ones are clear. In order to dilute it, we actually had to dilute it in benzene because it has very low solubility in organic solvents.